Lesson 78, Graphing Rational Functions. A rational function has a variable in the denominator. Okay, so that is the definition of a rational function. It has to have a variable in the denominator. Excluded values, this is something that we should already know by now. Remember, excluded values are the values of the variable that makes the expression undefined, and it's undefined where the denominator is equal to 0, so whatever the denominator is, we can set it equal to 0. Those are excluded values. Rational functions are discontinuous and have asymptotes. Okay, that means that they're not one smooth line. Okay, you can see that these are two separate lines; they do not connect. And the asymptotes. Okay, we have a horizontal asymptote and a vertical asymptote for this function, and the lines for this function, the graph, is going to get as close as it can to those asymptotes, but it will never cross it. Oops, I forgot something. Okay. When in the form y equals a over x minus b plus c, okay, this is where we're getting this from. This is the standard form of the rational expressions or rational functions. The vertical asymptotes occur at x equals b, okay, so if I want to know where the vertical asymptote is, I set x equal to whatever b is. Notice that this is a negative, okay, that's important because if this is a positive, then that means that b is actually negative, and if it's negative, then b is actually positive, okay, because that's the actual formula, the equation for it. Then for the horizontal asymptote, it's where y is equal to c. So I would just set y equal to c. So since this is positive, if it's a negative, then it has to be negative. Alright, so it says identify the asymptotes. So first of all, I'm going to rewrite my standard form for these functions, which is y equals a over x minus b plus c. Okay, on this one, it is in this form except for it doesn't have the plus c. So I'm going to add plus, what can I add to this and not change its value? Well, that's 0. So all I have to do to find my asymptotes, okay, my first one is going to be where x is equal to b. And since this is negative and it's negative in my formula, then it's just 1. And then y, I set equal to c, which here is 0. So my x, remember, is going to be my vertical asymptote. It's the one that goes like this. And my y is my horizontal asymptote. So at x is equal to 1. Okay, so x is equal to 1 right here. This is the asymptote for that. And y is equal to 0 right here, so there would be an asymptote at the x-axis. Sorry. Okay, on this one, exact same thing. We're using that original formula, which is y equals a over x minus b plus c. So to find our vertical asymptote, we're going to say that x has to be equal to b. Well, b in this case is 3, so x equals 3. Y is equal to c. Notice it's plus c here, but minus 10 here, so it has to be negative 10. That's it. Okay, vertical, horizontal. Oops, wrong button. Okay, so it says identify the asymptotes and graph each function. So I'm going to, again, start by writing that formula, y equals a over x minus b plus c. So for my asymptotes, my x is equal to b, which is 3 here, and my y is equal to my c, which is going to be plus 0, so just 0. So x is equal to 3 right here, so my asymptote is going to go like this. My horizontal is at y is equal to 0, y is equal to 0 right here, so it goes like this. Oops. Okay. Then for us to graph it, we can do a t-chart, okay, which they give us right here to do. So looking at what we have, I always like to make it stuff that's easy for me, okay. So if I chose like 2, because if I put in 2 here, I would have 5 over 2 minus 3. Well, that would be 5 over negative 1, which is just negative 5 for y. The next one that I might choose would be, we'll say 8, because if I put 5 over 8 minus 3, that would be 5 over 5, which is equal to 1. Okay. I could also use, I'm trying to avoid getting fractions and decimals. If you do, it's fine. It's just a little more of a pain whenever you graph it. So the next one, I don't want to go too big because I only have so many spaces on my graph here. So let's do, we do 13's too big. Go negative 4, we go 5 over negative 2 minus 3. So that would be 5 over negative 5. So I said for x I was going to put in negative 2, which got us a negative 1. We could do 5 over, and to get this to be a 10, I would do negative 7. So I would have 5 over negative 10, give me a negative 1/2. So this was negative 7, this is negative 1/2. If I do, okay, let's just go ahead and do, we'll say 5 over, to get this to be a 10, it would have to be 13 minus 3, which is going to be 5 over 10, which is 1/2. See how my scratch work here? So I said I was going to put 13 in for x, and that got us a positive 1/2. Okay, so we'll go with what we have here. So my first point is at 2, negative 5. So I'm going to go over 2, down 5, 1, 2, 3, 4, 5. Then my next one is at 8, 1. So I'm going to go over 8, 1, 2, 3, 4, 5, 6, 7, 8, up 1. My next one is at negative 2, negative 1. So if I go negative 2, 1, 2, negative 1. Okay, the next one's at negative 7, negative 1/2. So I go negative 7, 3, 4, 5, 6, 7, negative 1/2. It's about there. If I go to 13, I get 1/2. So if I went over to 13, it would be about here. Okay, so I have what a graph that looks like. Pretend that I'm actually hitting those points. Looks like this. Okay. Okay, same thing for B. I'm going to find my asymptotes first. So I have y equals a over x minus b plus c. So for x, I set it equal to b. B has a negative here. Since it doesn't have the negative, it's a positive. It has to be negative 2. Y equals, I just set it equal to c, which is 5. So I'm going to draw my asymptotes first. X is negative 2 right here. So I draw my vertical asymptote through that point. Y is equal to 5 for the other asymptote. So 1, 2, 3, 4, 5. So I'm going to draw my horizontal asymptote. Maybe these do go out farther. 6, 7, 8, 9, 10, 11, 12, 13 would have been on the edge there. Okay. So then what I'm going to do is create my table. So I'm going to rewrite this. Y equals 3 over x plus 2 plus 5. Okay. So values for x, if I plug in 1, I will have 3 over 1 plus 2 plus 5, 1 plus 2 plus 5, which is going to give me 3 over 3, so it gives me 6. If I plug in, let's go 3 over, this is a 2, right? 3 over 4 plus 2, all plus 5. That's going to give me 1/2 plus 5, so 5.5. So if I plug in 4, I get 5.5. If I have, let's go 3 over, let's say, -5 plus 2, plus 5, plus 5 equals, so this is going to give me -3 on the bottom, so -1 plus 5 is 4, so that was a -5 for x, and a +4 for y. If I go 3 over, and we'll instead change that to -8 plus 2 plus 5. So this gives me -6, so it's a -1/2 plus 5 is going to give me 4.5. So I put in -8, and I got 4.5. So let's graph the points that I have here. 1, 6. So I'm going to go over 1, up 6, right there. The next one is at 4, 5.5. So over 4, 1, 2, 3, 4, up 5.5. So about here. Okay. The next one is at -5, 4. So if I go -5, whoops, 1, 2, 3, 4, 5, up 4, 1, 2, 3, 4. The next one is at -8, 4.5. So this was 5, 6, 7, 8, and then up 4.5. So you can see that my graph is going to look like this and this, and it shouldn't touch there like it looks like it does. Okay, I'm not real great at drawing these with my tablet. I apologize. Okay, so it says Fiona is driving 150 miles on a business trip. She will stop for 2 hours for lunch. The time y in hours her trip will take is given by y equals 150 over x plus 2, where x is the speed in miles per hour. It says, what is the equation of each asymptote? So we can write our original equation to figure that out. Y equals a over x minus b plus c. Okay, so first of all, x, which is my vertical asymptote, okay, this is my vertical asymptote, is going to be equal to b. Well, what's being subtracted from x? I could subtract 0 and not change anything, so it's going to be at 0. And then my horizontal asymptote is at y equals, which is c, okay, so right here I have 2. So those are my asymptotes. It says, for all practical purposes, what is the minimum time Fiona's trip will take? Okay, the minimum time that it would take. And it says, for all practical purposes. What they're saying there, for all practical purposes, is that her x, her speed, okay, x is the speed that she drives in miles per hour, she's not going to drive 150 miles an hour, right? No way she's driving that fast. The fastest that she can really drive and be within limits is if it's all highway, and that would be 70 miles an hour. So our equation was y equals 150 over x plus 2. So I will put in 70 because that's the fastest that she could go. And if she does not stop, okay, this will be her speed. So I would get, let me get out my calculator here, 150 divided by 70 is going to be 2.14. Okay, or it's 2 1/7 plus 2. So y equals 2, not 2, let's just scratch that. Y equals 4 1/7. So this is 4 hours, and 1/7 of an hour, we could take 1/7 times 60, see about how many minutes it is. So it would be about 4 hours and 9 minutes. That's the fastest that she could do it and not be driving a ridiculous speed. So that's all I have for you. I hope that you have taken good notes and that you have a good night. I will see you in class tomorrow.